Find the volume of the solid obtained by rotating the region bounded by the curves y equals x and y equals x squared. And we're going to rotate this about the y-axis. So y equals x and y equals x squared. The graph will look like that. They intersect at 0 and 1. If you need to do the algebra, you would just set them equal to each other, or x is equal to x squared. And don't divide by x though, just subtract it over. Let's say 0 is x squared minus x, and then factor out an x. So that's why they hit at 0 and at 1. So yeah, and then first question is what's the axis we're rotating about? It's the y-axis. And so if we're rotating about the y-axis, the question is first, is there a gap between your region and your axis? And the answer is yes. And when the answer is yes, you have to choose between washer and shell. With washer, your rectangle will be perpendicular. The rectangle will be perpendicular to your axis of rotation, and with shells, it's always parallel to your axis. So with the washer, we'd be doing this perpendicular. With shells, we'd be doing this. I don't know. Let's if we're doing it in washers, the variable would be in y this time, and will be in x for shell. This guy would be moved horizontally in x. This guy would be moved vertically in y. Yeah, either one's good. I'm gonna go with a washer. Just we've seen a disc and a shell, so let's see a washer now. The volume for a washer is equal to pi times the integral from some a to b of the outer radius squared minus the inner radius squared. This is my outer radius and this is my inner radius. And then and it's going to be dy for us. How do you get the outer and inner radius? Well, the inner radius comes up and just meets your rectangle, and the outer radius goes all the way through and gets to the end of your rectangle. Okay, and those are x distances because they are the distances off of the y-axis. So those are x distances, but our integral is in y, so we need to do a transformation. This guy is called y equals x. This guy is called y equals x squared. And so the inner radius is to the line, so that'll be y. The outer radius is to the curve, and we can just solve that for x by taking the square root. And so the square root of y would be what x is. And so we take the square root of y and square it, and we take y and square it here. From what to what? This thing starts at a low point of 0 and you're done at a high point of 1. You're going to move this thing vertically upward. So those are your limits of integration, 0 and 1. And you have pi. Oops, 0 and 1. And you have pi on the outside. And this is a dy integral. Square to square root, just get y. And so y minus y squared from 0 to 1 works out really well. Not that shells wouldn't work out well too. We just decided on washer. Y squared over 2 minus y cubed over 3. from 0 up to 1. When it comes time for 0, we don't have to worry about that. It'll be pi. If we put in 1, we get a half minus a third. And then put in 0, we get 0. So half minus a third, common denominator is 6. So that'll be 3 sixths minus 2 sixths. Altogether, that's 1/6. So your answer is pi over 6. Whatever units we have cubed, that's what we get when we rotate that and create that three-dimensional shape.